Hello, welcome to my project demo. In this video, I'll walk through a yoga pose application I developed using Python, Flask, and MySQL. This project collects yoga poses from the yogajournal.com website, stores it in a MySQL database, and then makes that accessible through a web interface here. This project was inspired by my own experiences working from home, sitting for extended periods of time at work, and a lot of times I was just sore and feeling uncomfortable. I also use a Pomodoro clock regularly for productivity. And during those breaks, I found myself searching for quick yoga sequences or poses to do during those breaks just to stay loose throughout the day. So I decided to create this app that'll allow users to find poses targeting specific body parts that they'd like to stretch, like the hips, shoulders, lower back, etc. So when a user inputs the body part that they'd like to stretch, the application provides a list of dictionaries, a list of these poses designed for that specific body part. And I opted for the search to use body parts because it'd be useful for beginners who may not be familiar with the yoga pose names in English, let alone in Sanskrit. But that information is provided in the output. So for each pose, the output contains the English name, the Sanskrit name, the pose type, as in like a hip opening, a seated pose, a twisted pose, etc. And it also includes step-by-step instructions. So let's take a look at this app in action. So here you can see the Flask web app running with a very simple interface. And when you search, the application will query the database. And like I said, it'll return a list of dictionaries. So let's look for, today I'd like to stretch my hips. Again, it returns a list of dictionaries. And in each of these dictionaries, we have all of the attributes, right? The English name, the step-by-step instructions, pose type, hip opening, seated, twist, Sanskrit name, and the target body parts. Let's look for another body part. What about my back and my hips? So again, it'll spit out the same list, but these are obviously different poses because we're targeting a different body part here. And if I want to look for something that is not in this database, let's see, I would try to stretch my head. It'll just print out no poses found for this body part. So let's take a closer look at how these different components of the project work together. Let's start with this app.py file. This is the main entry point of the Flask app. So this will initialize the Flask application, defines all of the routes, and this integrates with the service layer as well here. So this route here handles our GET requests. And so this will retrieve the body part parameter from the request. It queries the service layer, and then it'll return the results. And so again, if it's not in our database, it'll return no poses found for this body part that we saw earlier. So with respect to object-oriented principles, this file focuses solely on handling the HTTP requests and responses and delegates the business logic elsewhere. So let's look at the yoga pose. This is a very basic class here that defines yoga pose class. This encapsulates the attributes of each and every pose. In the future, when more features or attributes or methods are added, this will also need to be updated as well. Yoga service.py, the purpose of this file is to handle the main tasks of finding poses and then adding them to the database. This relies on the repository interface to manage all the interactions with the database. So when we create a yoga service object, we need to give it a tool that knows how to get and save data in the database, and that is the repository. So the yoga service just asks the repository to fetch or save the poses without worrying about any of the details of how that's done. The main one for this app is get poses by body part. And with respect to object-oriented principles, this class adheres to dependency inversion principle because it depends on an abstraction, which is the repository interface, rather than a concrete implementation, as we have in the MySQL repository. So this separation allows the yoga service to interact with different types of repositories without being coupled to a specific one. So let's look at that repository file. So this defines a base class for all the repositories. This defines the interface, and it uses abstract base class module. This interface specifies the methods that any repository class must have, and by virtue of that, all of the subclasses. So by defining an abstract base class, this can support different types of data storage, whether it's MySQL, SQLite, or something else, without changing any of the core business logic. The key idea here is that this uses the abstract base class to make sure that any subclass implements the same specified methods that we have here, and we can find these in our MySQL repository file. So this handles all the interactions with the MySQL database. This inherits functionality from the repository pattern, and this just makes sure that the data layer, again, is decoupled from all of our business logic here. So the class constructor sets up the database connection using these configuration details, and it creates a cursor for executing SQL queries. The main method, again, like we've seen before, is the get poses by body part. So this executes a SQL query to fetch poses and uses a like clause here to search for poses where the target body part matches the input string and gives a list of those poses. We also have add pose, which inserts a new yoga pose into the database using an insert command. And for the future, when we want to retrieve a pose by the name, we'll use load pose, and this will just retrieve a single pose based on its English name. So with respect to object-oriented principles, the key idea here is that there's a separation of data access logic from the business logic. Some of our additional files here are index.html. This is inherited or recycled from Jeff's repository. And so this is just the front end part of the application. And this just gives the interactive elements that a user would use for poses, for searching for poses and reading all of their results. And then our init.sql here sets up the database. So this includes all the necessary SQL commands to create our tables, defines how the data relates to each other, and just make sure that everything is in place and ready to go. So thanks for your attention. Moving forward, I plan to add a lot more features to this. I'd like to integrate different types of Pomodoro clocks. There are 25-minute ones, 50-minute ones, different kinds. I definitely like to expand the database with more poses and different styles as well. I'd also like to include longer sequences. So instead of just a single pose, a series of poses, which would just be in a sequence. Simple ones like simple sun salutations. And obviously, this user interface would definitely need some improvement as well. But thanks for watching, and I hope you find this demonstration to be useful.